So, what I'm going to do today is I'll do my best to recap Algebra 2, Quarter 2 for you. I'll give you kind of the general ideas of what we kind of covered. And then what I really want to do is more interactive. I don't really think I'm going to teach you anything new today. I'm just going to teach you to take all of the pieces that we learned and put it all together. That's all we're going to do. So what I'd like for you guys to do is you guys get up on the board. I will support you. I will help you. We will help each other. I promise. It won't be a big embarrassment fest or anything. And then, how's that sound? Does that sound all right? Does that sound creepy or freaky or like I can't bear to do that? Or all right. And whoever joins me online, jump in on this. Hopefully you guys get this. All right, so check this out. Polynomials. See, I can't remember. I didn't check up on your grade. It's not that good, is it?
I have a C.
A C? Okay, all right. But is it Poly 2 that's bugging you?
Yeah.
The polynomials, Quarter 2?
Yeah.
That's what's bugging you? All right. To be honest with you, I find that a lot of students have been finding this stuff way easier than Quarter 1.
Yeah.
But if you don't understand it from the beginning, then you kind of get lost, I think. So let me kind of recap for you what's going on. We have f of x. This is a function ax plus b. We usually see that as mx plus b. That is way too low quality for you to even see. Let me see if I can get this as a higher quality camera. Stop sharing that. Up the webcam. Let's go with high quality. Start sharing. All right. And then let's see if we can even get the lights and all this out. All right. Is that more visible to people?
I don't think no one's there.
Yeah, I don't think anyone's there, but I want to make sure that people can see that in the recording. Anyway, f of x equals ax plus b. That's the equation of a straight line, right?
Right.
Straight line. Cool?
Yes.
And then we have another kind of thing is f of x equals ax squared plus bx plus c. We're pretty familiar with that one as well. That is the equation of a parabola. Cool?
Yep.
I'm going to go through this. I'm going to recap the whole thing, but I'm going to do it real quick. You slow me down. Because when I did it with the girls yesterday, I did it real slow because they didn't turn anything in. But at least I know that you're kind of, well, be vocal and let me know if you're having trouble, okay? ax squared plus bx plus c, that's that. F of x equals ax cubed plus bx squared plus cx plus d. That would be some kind of cubic function. Cool? F of x equals ax to the fourth plus bx cubed plus dot dot dot. And really you just kind of keep going with cx squared d, e, f until you get to the end. You know, if you don't have an x anymore, then you just do one more and then that's it. Cool? I'm not going to write down the standard form for every single one, but this graph looks kind of like this. Are we cool? All right. Some things that we notice. Yes?
There's one less bump for each, higher exponent.
Do you understand that? One less bump for each higher exponent. This has an exponent of 4, or the highest exponent in this thing is 4, and there are 3 bumps. And I would say there are 3 bumps, but there are up to 3 bumps, right? Because these 2 bumps could actually come so close together that it looks like this. Technically, if I were to graph f of x equals x to the 4th power, that's where a is equal to 1 and b, c, d, and e are all 0. That graph would actually look like this. Which kind of makes you think, oh, that's a parabola. It's not a parabola. It isn't. It's this W-looking function with all 3 points kind of coming together so close together that you can't even tell they're separate.
What was that word you used? What?
A limit? Did I say a limit?
No,
Asymptote.
There you go.
That's not what this is, but I see what you're saying.
What is that?
I use the word asymptote. I forgot where I used that. I'm not sure if it was in this topic.
It was parabolas, because like you were explaining. No, wait.
We're going to hit asymptotes when we hit rational functions next quarter. That's where we're going to be hitting those a lot of. So remember that word.
How do you spell it?
ASYMPTOT. Anyway, yes, there is one less bump than the degree of the polynomial. Cool? Anything else you notice?
If you go by lines, then like instead of the bumps, if you go by lines, then there's just like
Oh, you mean there's 3 lines? One, two,
3 different
three?
directionals. Yeah.
Okay, I would be hesitant to say that they're lines, but yeah, I see what you're saying. Okay, what about the n behaviors of these different polynomials? What can you tell me about that?
When it's odd, the n behaviors go in opposite directions.
Yeah, see how this guy goes down and this guy goes up, right?
Yeah.
And then this guy goes down and this guy goes up, opposite directions. Whereas both of these guys go up at the extreme values. If I were to cover up the middle, it would, I don't care what the middle looks like. I just care about the end behavior. Then you would be able to say, oh, okay, if it looks something like that, then it's a even polynomial.
So leading polynomials, if they're odd, they go boom, and even polynomials go boom.
Well, you said leading, and leading implies that you're talking about the A. The A is just a number. We're talking about the degree of the polynomials.
Degree, okay.
The degree of the polynomials is odd, then they're going to go opposite directions from each other. Now, if the leading coefficient is positive or negative, a negative x cubed looks like this. It basically just looks like that, flipped over. We cool? They're still going to go in opposite directions in the end behavior, but this time it's going to be like a roller coaster going down as opposed to a roller coaster going up. We cool? And then similarly, your ax squared, that a flips them over, like that. Now, I wrote this in standard form, but I could write this in factored form. I don't know how to write that in factored form. There is no real such thing as factored form for that. But I could write this in factored form, and I could write it like a times x minus x1 times x minus x2. Right?
Yes.
This is the standard form. Here's the factored form. It's pretty straightforward. And this one's pretty easy factored form. It's a times x minus x1 times x minus x2 times x minus x3. And guess what this one is? X minus x1, x minus x2, 3, and 4. And then the fifth one, I mean, these are pretty easy to see, right? Now, what's nice about these factored forms is, when we get back to here, what's nice about this factored form is it's easy to see your x-intercepts immediately. I could write down, tell me what the x-intercepts of 5 times x minus 3 times x plus 1. What are the x-intercepts of that?
3 and negative 1.
Positive 3, negative 1. Got it? So immediately you can read off, boom, here's your x-intercepts.
It's always the opposite
You got it?
of
Okay.
the one that has.
One of the things that we started noticing when we did a few of these things, and I think this was from Ben, do your math. Okay. One of these things that we started noticing, and I think this was from the last polynomial chapter that we covered, so we're getting into advanced stuff now, is, see this one right here, how many x-intercepts does it have?
2.
Does it have to have 2?
No.
How, could it have 1?
Yes.
Draw me a picture of what it would look like if it had 1. I erase this one. You can draw me right there. Perfect. Okay. in that case, I would say that it's still a quadratic. It's still a second degree polynomial. But you would have x plus 1 squared, or something like that. Is that vaguely? Well, technically, the one you drew looks a little bit skinnier, so I would say like 4x plus 1 squared. We're cool with that? What's up, Cameron? Join us at the table. All right. The x plus 1 squared kind of tells you that it hits. I mean, what are the zeros of this?
Negative 1 and 8.
Negative 1 and negative 1.
Yeah.
So that's kind of what it does. It only touches at one point. Does that make sense? Could a polynomial have no x-intercepts?
Yeah.
Yeah.
Or could a parabola have no x-intercepts? Sure. There we go. When does that thing cross the x-axis?
No.
It never does. In that case, I don't think. I mean, you can write it in. Believe it or not, you can write this in factored form. Right? Isn't that kind of crazy? Because factored form tells us the x-intercepts immediately. How can I possibly write this in factored form if it doesn't have any x-intercepts to begin with? Well, that's when you get stuff like, I bet you this thing looks something like x squared, I don't know, I'm going to make it up off the top of my head, minus 5x plus 7. I bet you that looks like that. Now, this is the standard form over here. Okay?
Those are all prime numbers.
Well, what's the problem is I can't factor this. So if I can't factor this, one way of forcing factorization on this thing specifically is to use the quadratic equation, right? That would be negative b, so that would be 5 plus or minus square root of 25 minus 4 times 1 times 7. What's 4 times 1 times 7?
20.
Times 7, so like
28.
Yeah.
28. All over 2 times 1. All right, so that would be 5 plus or minus the square root of negative 3 over 2.
Negative square root.
Do you guys see a problem here?
Yeah.
Negative 3. That is an imaginary number.
Okay.
You see?
Square root negative.
So my 2 intercepts is at 5 plus an imaginary number over 2 and 5 minus an imaginary number over 2. That's why there are no x-intercepts. They're all imaginary. Do you guys see that? So this is a situation where you actually forced it not to have any x-intercepts. Cool? So not only can we take a look at a graph and tell, a lot about the equation, and also go backwards. We take a look at the equation and immediately tell a lot about the graph. We can take a look at the zeros and how those zeros look and tell you a lot about that equation as well. Let's try to do a few examples. So that's pretty much a recap of a lot of what you should know on polys. Did that help?
Yeah.
A lot of the rest of it has to do with, I think the last chapter we covered was long division of polynomials. And really, long division of polynomials isn't as hard as you think. I don't know. Have you guys had a chance to practice that?
Yeah. I was just wondering why you don't divide the next factors.
Oh, okay. Why do you just
Yeah.
work with the leading coefficient? It's just that's
Too advanced.
no, it's not too advanced. It's just you're taking too much into account.
Okay.
That's the way we do it. It's not. It would. Yeah, it is kind of advanced if you want to try to take everything into account at the same time. Okay. All right. So let me give you an example problem, and we'll talk all about it. Got it? Let me try. I'm gonna take a look at a graph, and I want you to tell me everything that you know about it. This is -4, this is -2, and this is 1. Okay. Everything you know about it.
It's a cubic function.
It's a cubic function. How can you tell?
Because it has two bumps.
Two
and
bumps.
The end behavior is.
End behavior is an odd kind of deal. Okay? What else can you tell me about it? Can you even tell me the equation off of it? What up, Bradley? Sure. Oh, I'm sorry. This is -4. Okay. Can you tell me the equation? Sure. I can tell you that it will look
0.5.
something like this if it's a
With
cubic
the
function.
0.5, right?
Huh?
Yeah, the leading.
Negative
A.
0.5.
What is -0.5?
That's the leading.
The outside.
Yeah.
Oh, you're ahead of me, but yeah, you're right. There's going to be a number out in front here, right? We usually call that number A. Are we cool?
Yeah.
X
This would be x
plus
plus
4.
4, x
plus
plus 2, and
minus
x minus 1. Are we cool with that? How did you guys figure out the A so quickly?
Because when
Negative
you
4
do the
times
y-intercept, it's
positive 8 divided by.
Do you understand how they got the A? Or would you like for me to explain that? This is actually y is equal to A times all of that crap. Are we cool? And then we could say, gee, if we only knew one number that is not on this, or that is on this graph, hey, that's a number that is on that graph. I don't want to choose one of my x-intercepts because I already used that information. But if I only knew one number, oh, it's right there. What are the coordinates of this number, Shannon?
0, -4.
0, -4. So you're telling me that if x is 0, then I guarantee you that y is -4. Is that what you're saying? So then what you say is, okay, you told me that -4, which is y, is equal to a times 0 plus 4, which is also known as 4, 0 plus 2, which is also known as 2, and 0 minus 1, which is also known as -1. I love plugging in 0 for x. It's like my favorite thing in the world. It just kills everything. 4 times 2 times -1 is
Negative 8.
-8. So -4 is equal to a, don't confuse that with a 9, it's not a 9, it's an a, times -8. So then you divide those. A is equal to positive 1/2. Cool? So that's the way they figured it out. They just happen to do it really quickly in their heads. Can I erase this part? So then your actual equation is 1/2. So how bad to the bone is this? We look at a graph, and I literally can spout off the equation.
Isn't it a negative 1/2?
No.
No, it's positive 1/2. Because I took -4 divided by -8.
The negatives cancel out.
Or think about this. Or think about this. This cubic function looks like this. If it were a cubic function that had a -1/2, it would look like this.
Yeah, the leading coefficient is negative.
Oh, I forgot about that.
I mean,
Positive.
you can immediately see. I can tell you. You asked me, wait a second, isn't that a -1/2? And no, it's not. Immediately, I mean, look at the graph. It is going up as you go. It's the roller coaster that goes clack, 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 ah, clack, 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 right? As opposed to going down.
All right.
That's the way I think about it. Of course, when you think of the roller coaster example, you have to think of it going from left to right as you go on this thing. We're not Japanese here, so we don't go right to left. We cool? All right. Okay, let's try another one. How's about this? I'm gonna switch it up on you. Because this is a really interesting question. Oh, sorry, is the camera backwards? There, is that better? I switched it. Sorry. That must have been very confusing for the people watching the archive. Come to class next time. Okay. Bradley, that's not your fault, I'm sorry. All right, I fixed it. Hopefully it works now.
Whoops.
Um,
That was my bad.
what can you tell me about the x-intercepts?
There's one negative and one positive.
There's only 2 of them. I can tell you exactly what they are. This is -1. This is +3. What can you tell me about the what kind of function is? What degree is this?
Cubic.
Second degree?
Third
Yeah,
There's
It's a third degree. I kind of see where you're coming from because you said, if it only has 2 intercepts, then it's got to be a second degree polynomial, right?
Oh, I just missed
because
that.
the
That
end
was-
behavior is.
No, but I can see where you're coming from. But cubic functions don't always have to have 3 intercepts. If I raise this graph up just a little bit, then it would have 3 intercepts, right? If I took the whole darn thing and I pushed him up, then he would have 3 intercepts, and I could understand that. But in this particular case, he only has 2 intercepts. We cool? How would I write the graph of that, or the equation of that? What's up, Vacation? So here's what you missed. All we did was recap what I covered with you yesterday. So you should be on the same page. Jump on board with us.
Do you see a phone sitting around here? Like a really cheap phone. Is it ugly? Is it not?
All right. So let's try getting this graph. And there's going to be an A times an X. It's going to be something like this, right? I didn't tell you what the third point on here, so I don't really expect you to get the A in this particular case. I'm kind of bored of doing that. We could just keep doing that and it would be the same process. That's not what I'm trying to teach here. What I really want to know is, tell me, is A positive or negative? Can you at least tell me that?
negative.
It's negative. It's the roller coaster. Got it? Alright, so A is negative. And it's negative, there's probably some number out in front, depending on how this graph is exactly shaped. Are we cool? Alright, what is going to go inside here? That's the question.
X
1 and
X plus
and
X
minus
plus 1,
3 squared.
X minus 3.
Squared,
Why squared? Why do you have the square on this one and not on that one?
because it's doing an intersect, or not an intersect, but
Uh,
only 1 point intersects
kissing.
another 3.
Kissing the 3.
Because this one it crosses straight on through. Right? But this one, it kind of comes up and kisses it and comes back down. When it does that kind of behavior,
It's like a parabola.
it's kind of like, if you zoom in right over here, it's almost like a parabola. If I were to block this part off, that looks like a parabola. And when parabolas kiss at one point, they have x minus 3 squared. As the previous one I just showed you. So look how bad to the bone we are. We're like reverse Desmos. In fact, I don't even think Desmos can do that. I don't think you can give Desmos a graph and say, what's the equation for this? But we can. We'll look at this and be like, that's what it is. I think that's cool. Today, what I want to do is basically refine your skills and turn you guys into a graphing calculator. And then basically, here's what I want you to do. Because this is what I love doing, is people would ask me, oh, what does this look like? How does this graph work? How does this thing? And I'll know my polynomials so well that I'll take a look at it and just be like, okay, here's the graph. And I'll draw some kind of, like, they'll ask me these crazy equations, and I'll take a look at it and just be like, all right, here's the graph. And then like that. And then I'll go like this. I'll go like this. I'll go like, booyah, I'm out.
That's a fun looking graph.
This we won't get to. This is called rational functions. We'll get to this next quarter. But
Asymptotes.
that's where we're getting to asymptotes.
ASYMP.
Yes,
TOT,
ASYMPTOTEs. All right.
like symptom.
Bradley, get out of here if something's happening to your dog. I hope everything's all right.
Oh dear.
All right. Let's try this one. I don't even want to. I just want to talk about it real quick. I just want you guys to do it as quickly as possible. What do you know about that graph?
4th degree.
Fourth degree.
Positive.
Ikeshi, do you understand why it's a fourth degree?
Yeah.
Why?
There's 3 bumps.
3 bumps.
And it's,
Perfect.
the end behavior is in the same direction.
And behavior same direction, so it's got to be an even. Okay.
Positive.
positive leading
And then you would have
Or x intercepts.
4 of those intercepts in the factored form, like this. And they would all be pretty standard. You just find out whatever numbers are, go in there and plug in the opposite version of them. That's it. We cool? What about this one? This one's going to be funky. Something you're kind of familiar with already. There we go.
One x intercept positive and third degree.
Third degree, 2 bumps, opposite directions. I agree. 1 x intercept. What is that other part going to be?
Imaginary numbers, so the negative
There we
radical.
go. What's going to happen is you're going to have something like ax cubed plus bx squared plus cx plus d. And then you're going to be able to take a look at, and I'm going to look at this graph right here immediately. And apparently this thing crosses at -3. So then I'm going to say something like, and here's where we get our other skills in on this, right? We'll say something like, oh, that means one of the factors of these 3 things is x plus 3. Right? And I don't know what those other 2 factors are. You see? Well, there's only one way to really figure out what goes inside of here. Because once I get what's inside here, I can factor that down and then get those other 2 pieces, right? I'll take this, and I'll use long division and divide that into this. And then I'll get something like hx squared plus kx plus j. This is just like ax squared plus bx plus c. I just didn't want to use a, b, and c because they'll be different numbers. Cool? So I just use a set of different numbers, h, k, and
Is
j.
there anything want to be shown up today?
What?
Is there anything want to be shown up today?
Okay. All right. So here's what I can tell you about what's going to happen here. I bet you that this thing cannot be factored. I bet you that when we plug this thing through the quadratic equation, you're going to end up getting a square root of a negative number. Just like how I showed you a parabola that doesn't have any factors. Because when you zoom in over here, it looks like a parabola that doesn't have any numbers. Or that doesn't have any real intercepts. Do you understand what's kind of going to kind of go on over here? I bet you that's what this thing might look like is something like this. X squared minus 5x plus 7. Remember, we couldn't factor that.
Yeah.
So if I FOIL this all together, I'm going to end up with this huge cubic function. And I'm going to immediately look at this and say, oh, okay, it's got 3 of these. The a is going to be positive because you're going up. It's going to be a cubic function going in opposite directions. But when I get here, I'm going to try factoring that. I'll plug that into the quadratic equation, and I'll end up with something like square root of -3 in my answer, plus or minus. You know what I mean? And I'll be like, wait a second, that's a problem. And then when I look at the graph, and I'm like, oh, I understand what the problem is. The dang thing don't cross the x-axis. So there's no more x-intercepts. No more real ones, in fact. We cool?
When do we learn about imaginary numbers?
Well, now you've learned about imaginary numbers. One of the questions that I really like, that's tough to answer, and I welcome it because I think it's really interesting, is what the heck is imaginary numbers used for? You know what I mean? Like, why the hell am I learning this? They're imaginary. What's the point of them? And my answer to that is this. Imaginary numbers actually show their head in a lot of interesting applications where you least expect it. One of the first places that I actually did see imaginary numbers is when you're talking about I got an extension cord here. And I have a paper clip. But when you're talking about electricity and you're talking about alternating currents, AC, what's really interesting is in order for electrical engineers to actually understand how this thing works, they had to graph things using imaginary numbers. Believe it or not, it's right here, imaginary numbers. There we go.
Oh.
Or here's another really crazy application that I thought was really interesting too. If you have two telephone lines, I know, crazy, huh? If you have two telephone lines and the wires hang like this, can you guys envision what I'm talking about here? And you have a bird sitting on this wire. This wire will start to swing. The first one, the one in front, will start to swing. And what happens is because of that, the resonating energy will transfer out into the telephone poles, into the other wire, and the other wire will start to swing. Right? Can you envision this in your head? A telephone wire, this thing starts to swing. This other wire will also start to swing. The relationship between these two phases of swinging is imaginary numbers.
Why? What makes them qualify? What?
Physics.
That is a calculus question, and it's not even a question of like, oh, that's too hard for me to explain to you. No, I just don't have the time right now. Calculus isn't as bad as you think it is. In fact, I think that what I'm going to do with the physics class is I'm going to teach them physics, but in the very end, I'm going to spend a lot of it on calculus. I'm going to straight up teach you guys calculus because I think that that's going to be fun. And I'm sure that a lot of you guys aren't taking physics right now, but too bad.
Shucks.
Is anyone planning on doing that?
Next year.
Yeah, they're like, I took chemistry from you. That was bad enough. I'm going to throw up a function. I want you to tell me everything you can about it. In fact, I want you to try to graph it. Okay? Let's see. Then use this. Okay, all right. Symbolic. Okay. Let's try this. X4 minus 2x squared, or minus 2x cubed, plus 10x squared, minus 18x, plus 9. Question. What is the degree, Cameron?
4.
What is the leading coefficient, Acacia? Oh, good. You're good at this stuff. Okay. What is the potentially is the number of zeros? There could be how many zeros?
4.
There could be 4 zeros. Could there be 5 zeros?
No.
No.
Could there be 2 zeros?
Yes.
Could there be 3?
Yeah.
Actually, no.
Oh.
If there's 4 zeros, it would look like that, right? To the 4th power, n behavior looks like that. 3 bumps. Acacia, what are you looking at? Give me your computer. You know I love you. Give me your computer. All right. Then just put it away. It could have 4 It could have 4 intercepts. Boom, 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 boom. Got it? It could have 2 intercepts. How could it have 2 intercepts?
If it's just kissing the, yeah.
Oh, you're right. It could have 3. I didn't think about that. You're right. I was wrong. It could have 2. It looks like that. But you're right. How could it have 3 intercepts? Well, it could have these 2, and then I drop this thing down just a little bit more and have it kiss that. That would be 3 intercepts. Touche. Excuse me.
Then it
No,
could
you're
have
right.
1.
It could have 1, yeah. Could it have 0?
Yes.
Yeah.
I could just take this whole darn thing and push it up so high that it never touches the x-intercept. We're cool? What's the y-intercept of this graph?
9.
Dude, how'd you get that so quick?
Because of
Acacia, how did she get that? How did he get that so quick? Do you understand? Right. Good. Let's see. If I were to tell you that one of the zeros, actually, we'll do an easier problem than this. Okay, let's do another one. Cameron, do you feel like you got this enough for you to try one? I'll support you. I'll help you. I promise.
Okay.
All right. Let's do x cubed minus 3x squared plus 3x. Oh, I'm sorry, minus 3x plus 1. Okay. F of x equals. All right, x cubed minus 3x squared minus 3x plus 1. I want you to tell me everything you know about it. I even want you to graph this for me. Or I'll graph it for you. I'll tell you what the graph looks like. It looks like -1 and 1, 2, 3, 4 here and there. So -1, I can definitely see from the graph. Here's 1, 2, 3, 4. Here's the problem. I don't know what that is. I don't even know what this is. Do you understand? Here's what I want you to do. I want you to figure out what those are. There you go. I'll walk you through it. You ready?
Okay.
First of all, degree.
3.
Good. Leading coefficient.
1.
Okay. Does that look like a cubic function that has a 1?
Yeah.
Perfect. What are the total number of zeros? You can look at the graph to get this.
3.
There's 3 of them. I can't write this straight into factored form because I don't know what that is.
Mhm.
So, oh, and what's the y-intercept?
1.
Perfect. Okay. Now, how can I figure out those other 2 intercepts? Do you know how to do
by
it?
using the quadratic.
You can use the quadratic form. The quadratic formula can be used if I had this. If I had not an x cubed. The quadratic formula can only be used if I have an x squared. If I have an x squared, a quadratic function. I have a cubic function, my friends. What do I do?
Long division.
Would you do this thing? It's something along the lines where x would be
Perfect. Just write up the x.
3x minus 3 plus 8x plus 1.
All right, here, back up. What the heck did you do?
Well,
You did the long division.
You did not do the long division in your head.
Huh?
Did you do the long division in your head?
I think so. I don't know what I did.
No. All he did was he took off this thing. He's like, oh, it's x plus 1, and then I'm just going to take that and write the rest of it. No, you can't do that.
No, you can't do that.
No, you can't do that.
Oh,
And that's
that-
not
why?
right.
Why not?
Because when
Because
you distribute it, it's
Because essentially what I'm saying is this. Essentially what you're saying is this. This times this is equal to that. And if that times that were equal to that, if you want to FOIL that out, I'll prove it to you. That times that is not going to be equal to that.
Huh.
You see what I mean?
Yeah.
Good try. You want me to finish it off for you?
Yes, please.
All right. Good try. And I'm going to go off. I'm going to continue on that idea of this times this is equal to that.
Okay.
I've got something times something, and I know that this is x plus 1
yeah.
is equal to that. So what I'm going to do is is equal to this thing. Got it? Acacia, you got it? So what I'm going to do here is I'm going to take, to find that something, I'm going to take this thing and divide it by that. Do you see that? Now this is what I didn't cover with you yesterday. This is long division. X cubed minus 3x squared minus 3x plus 1. I'm literally going to do long division like this. All right, Acacia, do you remember how to do long division?
Yes, with numbers.
Okay, fine.
Yeah, that's it.
Shannon, are you cool with this long division? Or you wouldn't mind seeing an example?
Can you give an example?
Okay, all right, I don't mind doing an example. For you, okay. I don't know, I'm going to make it an example off the top of my head. How's about 5, or 95 divided by 5? Got it? I'm going to take your phone pretty soon.
What for checking the time? What is the problem with that with what I'm doing? I'm listening to you.
No, I want you to actually pay attention.
I'm paying attention.
Okay, ready?
No, you back, whatever.
95 divided by 5. Let's just kind of warm up with this idea. Cool? How do you do long division? Actually, we'll do like 950. No, let's do 945 divided by 5. Make it a little bit more interesting. How do you do long division? Come on, tell me all the steps. This is real quick.
So 5 divided by 9 first.
How many times does 5 go into 9?
1,
One time.
and then you
Multiply here.
multiply
Put a
there,
5 down there.
and put a subtraction.
I'm going to put a subtraction. Instead of putting a subtraction, I like just thinking of it as adding a negative. Cool? So what is 9 plus negative 5, which is what? 4.
And then drop down the next
And
number.
drop down to 4 again. How many times does 5 go into 44?
8.
8 times. Put an 8 up here.
And then
8 times
minus-
that, that's 40. Cool? Add a negative. Same as subtraction, but add a negative. 44 minus 40 is 4. Drop down to 5.
And then
How many times is
9?
Yeah, so you put 9 over there. Cool? Then you have 45. This is the same. The remainder is 0. Are we cool with that? You remember long division? All right. I'm going to do a long division on this crazy looking thing. And it's going to look horrible, but it's not bad at all. Literally, you do the exact same steps as if you did here. Like what I would do is I would do this problem, write out each step that I did. Step 1, step 2, step 3, and then follow those exact steps on this thing, and you'll get the answer. All right, I'll show it to you. You ready? How many times, what do I have to multiply x squared, or I gave you the answer. What do I have to multiply x cubed by to make, or what do I have to multiply x by to make it x cubed? X squared. Because x times x squared gives me x cubed.
Yeah.
Just like,
Following the exponent rules.
yeah. So, all right, now I'm going to multiply x squared into here. When I multiply x squared into here, I have to distribute x squared here and x squared there. So then this would be
Minus,
x cubed plus x squared.
and then you
Do you see that, Acacia? Did you get that first step? Do you understand where I got the x squared from?
Yes.
Okay. Then what I did was, on the side, I'm going to do this. X squared times x plus 1. The x squared has to distribute into here. X squared times x is x cubed. X squared times 1 is x squared. We cool? What's going on, Brandon? You wanted to learn some algebra?
Yeah.
Cool.
I like math.
What I'm going to do is I'm going to subtract this. But I always get screwed up when I just put a minus sign out in front. Because that looks to me like, oh, I'm just going to do that and then do that, right? What I like doing is I like thinking, oh, I got to subtract the whole darn thing. So instead of subtracting, I like adding a negative of that whole polynomial. Does that make sense? Just like how I keep on saying I add the negative as opposed to subtract. All right, so this is negative 4x squared, right? And then this is 0. Cool with that? What do we do over here? We drop the number down here. Well, we're going to do the same thing here. Drop that number down and we have minus 3x. What do I have to multiply x by in order to make it negative 4x squared? Shannon. What do I have to multiply x by in order to make it negative 4x squared? Close. If I multiplied it by negative 4, then it would just be negative 4x. I want negative 4x squared. So it's not negative 4. It's not just negative 4. It's negative 4x. Because now if I multiply this by x, it would give me negative 4x squared. We're cool? Well, of course we're cool. Are you cool?
Yeah.
All right, good. I'm going to multiply this thing through by negative 4x. So then I go negative 4x squared minus 4x. I'm going to subtract this thing. By subtracting, I mean I'm going to make everything opposite sign and then just add. This becomes 4x because negative 3x plus 4x is, no, I'm sorry, this becomes 1x. And then this becomes 0. We cool?
Yeah.
Drop this sucker down. So x plus 1. What do I have to multiply x by to make it into x? 1. Okay. Multiply by, over here you get x plus 1. That gets a remainder of 0. We're good. We're good. So I know what's in the question mark. What's in the question mark is x squared minus 4x plus 1. We're good there. Now, can I erase this? Okay. Now what I asked Cameron to do is I told him, hey, I knew how to find this one. I don't know how to find these two. Now, Cameron, can you find those two?
Yeah.
I can factor that. Oh crap, if I could factor that.
Yeah.
I don't know how to factor that.
Oh.
Is there a tool I could use that will guaranteed factor it?
Quadratic equation.
Desmos.
True that.
Well, no, Desmos will only
Oh
give
wait, no,
you.
it's graphic.
Desmos will only graph it for you, and it'll only give you like an approximation. We want like this the exact answer.
Quadratic formula.
The quadratic formula. I guarantee you, you hit that sucker with a quadratic formula, it will give you these two answers. And because of the fact that I couldn't just factor it in my head, I know that these answers aren't going to be nice numbers. I bet you that it's going to be x minus some number that's a decimal. You know, decimal.
Right.
And then x minus some number that's another decimal. In fact, I could even guess for you what those decimals are when I graphed it. I told you this was 1, 2, 3, 4. So I bet you the decimal over here is going to be like 0.5738 or something like that. And the decimal here would be like 3.42 or something like that. You know? In fact, why don't we just not wimp out and actually do the quadratic equation and see what the answer is. Negative b, so that would be 4 plus or minus the square root of 16 minus 4 divided by 2. Is it right if I didn't baby step the quadratic equation for you? Can I just pull that out and just like write it down real quick? All right, good. Because we covered that in quarter 1. All right, so then that would be 4 plus or minus the square root of 12. The square root of 12 is what?
Any rational.
Use a calculator. Anyone got an iPhone on them? Yeah. Four
Oh, I don't-
plus the square root of 12. What the heck?
I turned mine off.
Oh, Siri doesn't work.
Yeah, sorry.
Siri,
He
anyone?
also doesn't do math problems anymore.
Andre, can I borrow your phone? Andre's phone does it.
And then
I have
use
Samsung.
iPhone, it doesn't do math problems. I don't even know. It'll be like, do your homework, and I'm like, okay, Siri, you're being rude.
4 plus the square root of 12. Actually, I don't think I got too excited. Oh.
You can like type it in the calculator.
4 plus the square root of 12.
Okay, give me a moment.
7.46.
The answer is approximately 7.4641.
I wonder if I can just do this. Divided by 2.
I'm not sure I understand.
Okay, fine. Parentheses. 4 plus the square root of 12, close parentheses, divided by 2. I wonder if she's that smart.
I don't think.
Let me think about that. The answer is approximately 6.44949.
No, it's not it.
Oh,
Fine. 4 plus the square root of 12.
I couldn't find anything about 4 plus the square of 12 on the web.
4 plus the square root of 12.
Let me check on that.
7.461.
The
All
answer
right,
is
so
approximately
so-
7.4641.
7.4641. 7.4641 divided by 2.
The answer is about 3.732.
3.732. 3.732. There's your other factor, my friend. 4 minus the square root of 12.
Let me have a look. The answer is
0.5358.
approximately
0.5358 divided by 2.
The answer is 4.
0.5358 divided by 2.
That would be 4.
0.5358 divided by 2.
It's 0.2679.
0.2679. Booyah! All done. All right.
you should ask Siri where you can hide a dead body. Those are always fun.
What is that?
You should ask Siri where to hide a dead body. Those are always fun.
Where do I hide a dead body?
I used to know the answer.
CIA is coming for Andre now.
What is that?
Actually,
The FBI are gonna be on his ass now because of you.
What did she say?
She said, I used to know the answer to this.
Hiding a dead body.
Back when I was a mob boss.
Yeah,
Yeah, the Siri update
actually,
took away all the fun
more
stuff.
graveyard.
Forget something like
Uh,
that.
I know.
I mean,
There was
you
a
know
dump
that
site
one
one as
time.
well. Like, that was the actual
Take your
mob
head.
boss.
Yeah, I know.
Your head
Siri,
out.
if this was, this is it's like riding a bike, being a mob boss.
It's not like losing your wallet.
I know. I used to be better at killing.
And
All right, I got a
then
question for
got
you.
everything.
I got a question for you. Here. I'm going to write this down. I'm going to draw this thing.
Got you.
Let's see what we can do. X to the 4th power plus x cubed minus 2x squared plus 4x minus 24. Woo! Degree.
4.
Leading coefficient.
One.
And behavior.
Shoot.
Yes.
It's good. Okay. I'll show you what the graph looks like. Is that a parabola?
No.
No. Is it a W? Yeah, it is a W. It's just those
Lopsided.
the bumps are kind of actually the graph looks even more like this, to be honest with you. Is that how many bumps does that have?
Does it have
It's hard to tell, but technically it does have 3. Those 3 just happen to be kind of close together, so it's not really bumping very much. Like I would say it's here, maybe here, and like around here or something like that. You guys see what I'm saying? So the reason why there's no official word for bumps is that because that's something we made up as a class.
No, I
Right?
know.
But it's kind of you can kind of see it, right?
Take the brownie and
What can you tell me about how this thing would look if I had it in factored form? And I'll tell you what these points are right here. This is -3, this is +2. What could you tell me about this?
It's +3.
x plus 3,
X minus 2.
x minus 2, and then what
Would
would you
square
tell me
those?
about
Or,
this?
no, would it be squared?
Would you square those? That's a
those
good question.
Other two are imaginary
If
numbers.
this thing bumped right
Nah.
here, if it kissed the graph right here, then I would square it.
Yeah. The other two are imaginary numbers, so
The other
negative
two-
radical.
The other two over here are imaginary numbers because it doesn't come back up and cross. It kind of goes like that.
Does that mean the long division is going to be more because you have 2 things put on the
If
other
I asked you to do the long division of this, you would say, "Man, you're such a jerk." That's what you'd say.
Okay.
What you would do, what I would do is this. I would go like this. I would go x. I'm not gonna do it for you. I'll just show you how to do it. x4 plus x cubed minus 2x squared plus 4x minus 24, and I would divide that by. Actually, let's not wimp out. Let's just do it. All right. Here. Here's what I would say. Here, I'll show you guys something. You guys, all right. I'll show you guys the stupid way to do it, and then I'll show you the way that I would do it. Because I'm taking a look at this and be like, "There's a quicker way to do this." Is that all right with you? Okay. The dumb way to do it would be this. You would divide that by x plus 3. Why x plus 3? Because I know that at least I know x plus 3 goes into here. I know that's one of my factors. Then I would do this long division thing, and I would get my answer, which would look something like x cubed plus, ax cubed plus bx squared plus cx, and so on and so forth. It would drop the degree down by 1, right? And then I would divide whatever I got for my answer divided by x minus 2.
Okay.
And then I would take that answer, and that would be whatever is in here. And then I know for a fact, I bet you, and then this would be an x squared, this would be a x squared degree, because I killed it down from an x4 to an x3, and then I killed that down by doing this process to an x squared. And then from there, I have this really powerful bazooka that I can shoot at the, quadratic function that's in here to get it so that I know what the factors are immediately. And that's the quadratic formula, and I bet you that quadratic formula is going to give me what kind of number?
Oh, imaginary.
Imaginary numbers, right? I bet you that's not going to be something I can factor using real numbers, so I would have to go into, I bet you that if I plug stuff in there, it's going to give me the square root of a -4 or something, a square root of negative whatever. So I have imaginary numbers to deal with. But I was thinking, there's actually an easy way to do this. Not an easy way, but I can do both of these steps at the same time. Instead of dividing it by x plus 3, and then going and then dividing that by x minus 2, I'm going to divide this by x squared
Yeah, that's what I was thinking.
plus x minus 6. Do you see what I did? Because I said, if I can take this thing and divide by x plus 3 and divide by x minus 2, divide out those things, and get my answer, right? Then what I could do is I could just multiply these guys together. If I foiled this, this would be x squared plus x minus 6. I hope you've gotten good at foiling in your head. I've given you more than enough practice, I guarantee it. So you should have gotten good at foiling at this point. So there we go. We cool? All right. I'll tell you what. Let's not wimp out and let's actually do this problem. I'll do it for you. It will be real quick if that's all right with you. All right. I'm going to go quick. Stop me if you're confused. Fair enough? Genesis, can you hear me? Are you even there? Is anyone here besides the people who came? No? I guess not. Okay.
she showed up and she's not even in the class.
I know. She's not even in the class. What are you guys doing? Come on, you guys. All you got to do is click a button. You guys can even go in from your underwear and just be like, I'm watching TV from my underwear. That's a little weird. Never mind. Don't. All right.
Smart underwear.
What do I have to multiply x4 by to get, or what do I have to multiply x squared by to get it to x4? Not 2x squared. I just got to do x squared.
Let's just say we were just talking about.
Got it?
Yeah.
I'm going to multiply x squared into every single one of these things. So this would be x4, this would be x cubed, and this would be negative 6x squared. Give me a second. I don't want to do this whole problem and then have to go back and say, oh, I screwed something up. Let me just make sure. X plus 3, x minus 2, foiling that, x squared plus 3x minus 2x minus 6. Okay, good. I just wanted to make sure I had the right thing. I told you I did it in my head, and I did, but I didn't want to screw that up. Sorry. Just doing some side work. All right, ready? Subtracting this means I'm going to subtract this whole thing, which means I'm just going to put a negative, negative, and a positive there, and then I'm going to add. That's the way it's easier for me to do.
So both of
So this would be
first two will cancel
4x
out.
squared. This would be 0, and that's 0.
Zero.
Cool.
Oh, you are.
Bring down
What
the
do you have
four.
to multiply? Oh yeah, I can bring down the 4x. What do I have to multiply 4x squared by to make it x squared? Or, no, what do I have to multiply x squared by to make it 4x squared? 4. That's pretty simple. Okay. Okay, so, interesting. I'm just going to multiply everything here by 4. That would be 4x squared plus 4x minus 24. Oh, I should drop this thing down too. Then what I'm going to do is I'm going to subtract this by going negative, negative, positive.
Everything will be 0.
Everything's going to be 0. So apparently this is what went inside of my question mark. Are we cool? That wasn't even bad. So my answer is x plus 3, x minus 2, and x squared plus 4. Now you think to yourself, wait a second, you're saying that was super confusing? Why is that so hard to, factor?
Because of the x squared.
Because you can't factor it. It's impossible. You can't factor that.
But, oh yeah, I was like,
Factor that for me. That's
Thank you.
x. What are you going to do? Right?
That's 2.
Like if we were to set this thing equal to 0, x squared plus 4 equals 0, and solve for x, try to figure out what the factors are, you would have x squared equals negative 4. X is equal to the square root of negative 2. X is equal to 1.41i. Yes, I know what the square root of 2 is. I just have done that particular problem so many times and happen to know that.
What is
It's
that?
imaginary.
Oh, that's what
I'm sorry, it would be plus or minus 1.41i. So technically, I could have broken this thing down. And I told you I can break this thing down into factors. This would be x plus 3, this would be x minus 2, and over here I would have x plus 1.41i and x minus 1.41i. Of course, you never write it like that. But look, broken it down completely. Booyah. Finished it. Peace out. We cool? Make sense? Alright. That was all Poly 6. In fact, I might have actually just did all of the homework that I assigned for that. Oops, I'm sorry. Your brains are totally fried. I'm going to wait for chemistry. I'm going to do chemistry. Can I go over Poly 8? And I'll tell you what. Poly 8 is the last polynomial chapter I'm going to cover. So actually, I think I'm in a dangerous situation where I think I've finished lecturing on everything I want to cover in quarter 2.
Too fast.
And I finished it too quickly.
This is a quarter end.
I didn't do
Christmas
Poly
break.
7.
Oh, never mind.
So we're not going to do that right now because the printer printed it up wrong. So I can switch over straight up to poly 8. Is it right if I just at least preview for you what poly 8 is about?
That's cool. I'm looking at that.
Yeah, that's fine. Poly 8 is, you're asking yourself, okay, here's what you're saying in your head. You're saying, all right, Mr. Daldig, you showed me how to do some pretty bad math. I can graph things with the best of them. I can look at an equation, tell you what the graph is, and be like, booyah, walk away. What the heck am I going to use it for? That's what you're asking yourself. So, poly 8 is about building a box.
Building a box.
Yeah,
Wait, a box.
A
As in
box.
Oh, box.
box.
the square
Let's do it.
on a graph.
You want to make a box for an art project. You only have one piece of cardboard that is 12 inches by 8 inches. And so you can cut, okay, so here's how we're going to make our box. It's 12 by 8. Here's how we're going to make the box. I'm going to cut a piece of square off here, 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 here. Like this. Can you envision how I'm making this box? I'm going to cut this thing out. Then I'm going to fold these pieces up. And then, make a box. Can you guys see that? I'll put tape around here and tape around there. All right. Can you see how I'm making this box? Yes? No? Okay. Here's what I'm going to do. I want to... How much of am I going to cut out? How big of a square am I going to cut out? I don't know. I'm going to call it X. How's that? So we'll call this X and X and X and X, 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 X and X. Cool? So now, can you envision the box that I have? You guys see that box? How tall is the box?
4x.
How big is it?
X.
It's X. It's X tall. How deep is this box?
8. Wait, no.
It's not 8.
X cubed.
8
Not X.
minus x.
It's not 8
Two.
minus X.
8 minus 2x.
8 minus 2X. Figure that one out? You got that? Ask him. Why is 8 minus 2X? Or do you
Because-
understand? This is not a yes.
So what's 4?
What is it?
So what's 4?
No, it's not. I don't know what X is. If X were
Wait.
2, then yes, it would be 4. But it's X, so I don't know what it is. It's just X. He's right. It's 8 minus 2X.
Why would it be?
Alright, they're
Because-
confused. Help them out, you guys.
So the total length of that side is 8, and we're taking away x from either side of it twice, so we're taking away x 2 times.
So it's 8. It would have been 8 minus an X and an X. Right? This length down here is the same as this length over here. That length over here is 8 because the full length is 8, and then X and an X. Cool? What about this length right here? What is that equal to?
Is it 12 minus 2x?
12 minus 2x. All right, here's my question for you. What's the value of this thing? The volume of this thing would be length times width times height, right? It would just be 12 minus 2x times 8 minus 2x times x. Guess what we have, my friends? A cubic polynomial. And then we could graph that. And we could say, here's the volume as depends on x. And then here's the really cool part. We can actually see where that volume gets the biggest. And we can say, this is the box that I could make with the biggest amount of volume. That would be helpful, right? Say we want to fill it up with Skittles or something like that.
it took a long time.
You'd want to have a box that would make the biggest amount of volume for the shape that you have. So there's where we got. There's where we get it. We cool with this?
Yeah.
Does it make sense? This is like a direct application of, oh, I see why I could do this. All right. Anyway, why don't we do this? I honestly think that's all Poly 8 is about. That's it. It's about doing this, and then once we get this, that was the hard part. Once we get this, we could FOIL that out and get a cubic function, figure out the leading
Wait.
coefficients, all of that kind of stuff.
Why would the vertical be x?
Because if I flip this side up, it's x long.
Oh.
You see, this is the box that I made.
I think I see it.
So this is
Once
the
you tape
cardboard I have, and then I took these pieces off, and I put tape around the edges like this.
So are we
Yeah.
like finding?
So we're finding the volume inside this box. Maybe we'll say, this is a piece of glass, and I cut off X off of here. And then I make an aquarium out of it. What is the biggest amount of volume I could have for that aquarium? So you see how this thing works? In case you missed the example completely, I explained chapter 8 in the time that it took you to use the bathroom. All right, we cool? You guys are done. Look, I finished all of polynomials today. On Monday and Wednesday next week, I'll probably recap. I'll probably cover Poly 7, and then I'll
So
probably
wait.
recap polynomials. And then that's it. I don't know if I'm going to teach you rational functions until quarter 3. So I almost feel like we're done with new coursework and new lessons. I'm not going to shove any more information into your brain. I'm just going to make sure that the information that I put in there is good.
Right.
I think the only other thing we're going to do from now until the end of the quarter is we're going to do a few standardized tests, training things. I'm going to
Okay.
make you guys take a bunch of standardized tests and get good at doing those. And that's only to help you out. That's only because I want you guys to do well in life.
Would it be graded?
Yes, I would grade those just because ungraded things provide no motivation whatsoever.
That is true.
All right, we cool? All right, I'm going to stop the recording. You guys can leave. I finished